Now let us solve part B, C, D. Part B says find the total energy E. The total energy is just 1/2 K times A squared. K is given, A is given. So it is 1/2, K is 50, A is 20 centimeters, but 20 centimeters can be written as 0.2 meter, and it has to be squared, so that E will be 1/2 times 50 times 0.04. And this becomes, when we multiply 0.4, 2 over 2, 1. So E will be just 1 joule. In SI, 1 joule. And part C is the maximum velocity. X max. We know that when the system is displaced maximum, or when it passes by the intermediate position, equilibrium position, when it goes to the maximum compression, it has considered these subsequent situations. Here it has, let me show the potential and kinetic energies. Okay. So when it is displaced maximum, it has maximum potential energy, this much, but no kinetic energy. It is at rest. When it passes by the equilibrium position at maximum speed, it has no potential because of no x, 1/2 kx squared is 0, but maximum, this area is the same as that area, maximum kinetic energy. When it is compressed maximum, then again it has all the energy and the potential for no kinetic, but when it passes by the intermediate positions, such as, for instance, here, when it is moving, maybe left foot, maybe right foot, but it has a certain x value and a certain velocity, in those cases, some part is potential, some part is kinetic, and the sum of these areas is the same as the single value. So we know this from Physics 101. In this case, it asks the maximum velocity. For the maximum velocity case, this is the x dot maximum. When it passes by the equilibrium position, it has maximum speed. All the energy is in the kinetic form. So that from the total energy, we can calculate the velocity. E is now all kinetic. So that 1/2 mv squared, but we don't say v, we say x dot squared, x dot maximum squared, is just totally, which is 1 joule. Mass is known, so that x dot will be, x dot squared will be 2 over m. What is that? 0.5 kilogram. So this ratio is 4. So that x dot maximum velocity is just 2 meters per second. So we obtain the first 3 parts. Now part D. We understand that in part D it is an underdamping case. Since the amplitude drops, in time, it is an underdamped case. It is an underdamped case, underdamped oscillations. So what is the equation for such cases? X of t was first e to the minus beta t and then a cosine part. Cosine was omega 0, omega 1t minus that, but cosine part, sinusoidal part is not very important because we talk about the amplitude. Now it says x, the amplitude at time t10, t equals 10 seconds, is 1/2 x of 0. This is the given information. But x of 10 can be written as e to the minus beta times 10, because this t, remember that whatever t we are talking about, it has to be this t and that t. However, the cosine part is not important because we are interested in the amplitude, magnitude. So it e to the minus 10, e to the minus 10 beta, beta is unknown, is 1/2 e to the 0. Cosine part is not important because we talk about the amplitudes. And amplitude, the envelope is determined by this first part. This is the envelope. This is the envelope. Remember, that is the sinusoidal part. Second part is giving the oscillations. First part gives us the, because remember that this was the shape for such cases. The envelope is the e to the minus beta t part, and these oscillations are represented by the cosine part. So cosine is not important in such analysis. Only the first part is important. And what is the time? 10 seconds. So x of 10 is 1/2 x of 0 at the beginning. Therefore, e to the 0 is 1, and we have e to the minus 10 beta is equal to 1/2. And of course, we do in such cases the following trick. We take the ln's of both sides to get rid of this exponential, and ln cancels, so we have minus 10 beta is ln 1 minus ln 2. ln1 is 0, so we have ln2. What is ln2? It is 0.693. What is negative? Of course, these negative signs will also cancel because beta has to be a positive quantity. So beta, the damping parameter, turns out to be roughly 0.07. What is the unit of beta? Beta should have a unit of inverse time. So when it is multiplied by t, second and 1/2 cancel and we get a pure number. So it has to be second to minus 1 or just hertz like the frequency. Beta is 0.07 hertz or second to minus 1. Let's have an example. A U-tube is filled with a U-tube of cross-section A. A U-tube of cross-section A is filled with a liquid of total volume V. That's it. So we have such a case. For example, this one is filled with such a liquid. It doesn't have to be water, and we only know the total volume and this cross section. This section is A. This cross section is A. So that this cross section, these are A. A is given so many centimeters square, for instance. If the liquid is made to oscillate up and down by just jostling, by just pushing one part downward, so that will make oscillations up and down continuously, is made, if the liquid is made to oscillate up and down, what is the period of these oscillations? What is the period T of these oscillations? Now, what happens when this liquid is made to oscillate up and down? Let me draw a simple picture here. So, for instance, this is the initial case. Of course, these are at the same level. The two surfaces are at the same level by the pressure, principle of pressure. Now let's compare the initial case with the oscillating case. For example, if you push one part downward by some piston initially, so that the two surfaces are not at the same level. For example, this part has gone down and that part has gone up by the same amount. Okay, this is the new position of the liquid, and let's give a name to this height. Let's say this height is, let's call it y. Of course, the other part is also y from symmetry. It also has 2y. So that this part is 2y. And it is this part, this initial part, that tries to oscillate the liquid up and down. It is the extra part of height 2y that oscillates the liquid up and down. So we should have an equation like m y double dot equals motive force. Let me call it motive force. Motive force here means this extra part that tries to work as a locomotive, for instance. Because the locomotive in a train is the only part that pulls all the rest. And it is this additional part that tries to oscillate all the liquid of mass m. Mass m we don't know. But we also know that rho is m over v. Density is mass per volume. Mass we don't know, density we don't know, but v is given. By the problem we are only given this volume and this cross section of the U tube. So this m can be written as rho times v. Anyway, rho's will cancel. The density is not given, but doesn't matter. And y double dot? Y double dot is the acceleration of the whole system, any part of the liquid, in the vertical sense. This is the y-axis, so we don't use x, we use y. It is better. That's equal to negative. Of course, in these oscillations, this part has to be written as negative term, because when y increases, the acceleration is in the opposite sense. So negative, the mass of this part rather the weight of this part. Weight of this part. What is the weight of this part? Cross section A times the height 2y. So this is the volume V prime. It's a cylinder. It is this part of the cylinder. Cross section area times the height. Height is not y but 2y. Because at this level the pressures are the same. And that column, this short column, is the motive force. Is the weight, that weight causes the object to oscillate up and down. So this is the volume. So we have to multiply by the density so that this becomes the mass of that part, and don't forget to multiply by g so that it becomes a weight. What about, first of all, these rows will cancel. We are not given, but doesn't matter. Next, it is written in the new form y double dot v times y double dot, let's take it to the other side, plus 2a g over, no, just 2ag times y is equal to 0. And let's try to make the coefficient of the first term 1, so divide by v. So then finally we have y double dot plus 2ag by volume times y is equal to 0. This is the equation of motion. And whenever we have this type of equations, whenever we have this kind of equation, what is that kind? For example, y double dot plus something y is equal to 0. X double dot plus something x is equal to 0. This type of equation, whenever we have, we know that this term, which is in this case 2ag over v, corresponds to the natural frequency squared, just like k over m. So this term should correspond to omega 0 squared. And we see as omega 0 squared this fraction. So that omega 0 squared will be 2ag over volume. Therefore, omega 0 is root 2ag over volume. But we want to have the oscillation period. Oscillation period. So that nu will be omega 0 over 2 pi. 1 over 2 pi and 2ag over volume. Therefore, the period will be t is equal to just the inverse 2 pi root volume over 2ag. Now we can make a short comment here. Finally here, short comment. What can we say about it? Volume, of course, as the volume gets larger, if you put a larger volume liquid in this tube, of course it takes more time to complete the period. G we cannot change. G we can change maybe if you do this experiment on the moon, where G is much less than the G on the Earth, then this G will be smaller, so period will be longer. If you do the same experiment on a planet or on the satellite such as our moon, since G becomes 1/6 of the gravitational acceleration on the Earth, period there will be longer. But the other thing which is practical is the cross-sectional area. The narrower the tube, A will be shorter, T will be longer. The narrower the tube, the longer the period. Not linearly, but in a square root manner. A to the minus 1/2. If you double the, for instance, if you increase the cross section, you can do this experiment by this tube or that tube, where A's are different. If you do this experiment, these oscillations in a narrow tube or in a larger cross-sectional area, larger case will have a greater denominator, shorter period. Period will be shorter, but here the period will be longer. We understand, we conclude that the area, cross-section area is more important. On the other hand, of course, as expected, volume is dependent, period depends on the volume, not linearly but in the 1/2, in the v to the 1/2 manner. And g also is inversely proportional. The greater the g, the smaller will be the period.